Alright, this is lesson 87 for 7th grade, and today we're going to learn how to multiply algebraic terms. And before we get into that, I want to review what we did with algebraic terms just the other day. We were combining like terms with them, so that was this. We're going to warm up with this. Combining like terms means we look for matching variable parts, okay? So, for instance, if I see an x squared here, I'm going to look for something else that has an x squared with it. They have to be exact. So, exact variable parts. So, x to the second, x to the second. That means I can combine this and this. And remember, it's important to include the sign in front of your term so that we know whether it's positive or negative. Now, we're going to combine these two. This technically means 3 plus 2, which if you want to think about it, this means we have 3x squareds, and this here means we have 2x squareds. So when we combine them, how many do we have total? Well, we have 5x squareds total. Alright? And the others that we can combine are 5x, positive 5x, and a minus 2x or a negative 2x. That means we're taking 5 x's and then we're going to subtract 2 x's, which will leave us with 3 x's. Alright, so our final answer in simplified form would be 5x squared plus 3x. And that would be our solution right there. Alright, letter B. We're going to look for, once again, those matching variable parts. So 7y, anything that has a y with it, but just one y. 7y and positive 2y. And then we can also combine negative 2x squared with a positive 3x squared. Okay? So matching variable parts. 7y plus 2y gives us a 9y. Negative 2x squared plus 3x squared, or negative 2 plus 3 is just 1. Alright, so there we go, that's our final answer, but remember we like to list them from largest exponent down to the smallest one. And we don't need this 1 here, technically that's just x squared. So it's x squared plus 9y. That's the best way to do that, okay? Now letter C, this tricked a few people today. We actually cannot combine anything for C because all of our variable parts are different. xy to the third and xy to the second. Okay, everything has to be exact. This is just xy, this is just x. So none of those can be combined because we can't group them together due to the fact that all of their variables are different. So C, we just leave as is because we can't simplify it. Alright, so that's kind of a review from yesterday, or combining algebraic terms. Now like I said, today we're going to learn how to multiply them. And this is a little different. So we'll recall that 3x plus 2x equals 5x. And once again, that means we have 3 x's and 2 x's. So if we combine them, we get 5x. So what does that look like longhand? This is x plus x plus x. And then this is adding on, plus 2 x's, and that means we're going to get a total of 5 x's. Alright, so my question today was, well, what's the difference then when we do this? What if we multiply 5 x's? What's that equal? X times x times x times x times x That is x to the 5th power. Remember, if we multiply the same thing over and over again, it depends on how many times we do that. But if we multiply 5x's together, that's x to the 5th. Alright? So that's the difference between multiplying 5x's and adding the 5x. Okay? So, we're going to keep that in mind when we move into multiplication today. The exponent does not change when we add, but it did change when we multiplied. Okay? And that's going to be a key today. So what happens then if we multiply 3x and 2x together? It would look like this. Okay? Now, multiplying, we can multiply any two terms together, or any 3, or any 4, or any 5, doesn't matter. And they don't have to look the same, because we're multiplying. We can multiply two things together whenever we want to. The rules are not as strict like when we add, because we can only add things that are of like terms. Doesn't matter here, and we'll see that in a second. But the important thing with multiplication is that we can reorder things. The commutative property says we can multiply in any order that we want to. So I'm going to reorder this to make it easier. 3 times 2, we know what that is, so let's do that first. And then we'll multiply x times x, just rearranging things. 3 times 2 is 6, and x times x is x to the 2nd. And there's your answer. So there's the difference between adding 3x and 2x and multiplying 3x and 2x. Notice how the variable changes when we multiply, but not when we add. Alright? So that's the main idea here. That's a very simple example. Here's a quick one down here I wanted to point out, because if you multiply two negatives, you get a positive. So, bringing back some rules here, and then you get x times y. Can't combine these because they're different bases. Alright? So here's something, this is kind of what the homework looks like tonight. We have 3 terms being multiplied together, and like I said before, we can just multiply everything straight through. Doesn't matter that they are not like. Could we add these 3 terms together? No, but we can multiply them together. So let's reorder some things. First of all, we want to get our numbers multiplied first. So negative 3 times 2 times negative 4. And let's just do that first. Negative 3 times 2, get a negative 6. Negative 6 times negative 4 gives us a positive 24. Okay, so now we got that taken care of. And then what we want to do is get our x's taken care of. X squared times x times another x. Okay? This technically means that we have x squared means x times x, and we've got these two hanging out. So how many do we have total being multiplied? 4 of them. So that's x to the 4th, 24 times x to the 4th. And then we've got some y's. We've got one y and another y. That's y times y. And that we can bring down right away because we just know that's y to the 2nd. So, solution. 24 x to the 4th, y to the 2nd. Alright, that would be the simplified version of this, which this looks a lot nicer than that. Alright? Keep that there. How about this one? Negative 2 times a times b times a squared times b times 3 times b to the 3rd power. Alright, first thing again, we want to get all of our numbers here. So, negative 2 times, this one doesn't have a number, that means we just have one of those. Okay? So, there's a 1 out front here, and then times 3. Well, negative 2 times 1 is just going to be itself, so that's negative 2. Negative 2 times 3 is negative 6. Alright? Next thing we want to do again is get our a's. So we have 1a and a to the 2nd, and that's it for a's. So how many a's do we have? This really means a times a times a this is 2 a's multiplied together, we have 3 total. That's 8 to the third. And then lastly, our b's, 1b, 2b, and then b to the third. How many do we actually have? This is b times b, and 3 of these. So 5 b's total. Solution, -6, 8 to the third, b to the fifth. So that's what that means, or that's how we do that right there. Alright? Got one more to do. And tomorrow, just like I let the students know, we're going to be doing this, multiplying, and we're going to be combining like terms so we can get a handle on the difference between the two. Alright. This is a rule that we had when we had a power to a power, and we can use that to solve a problem like this. Alright? Whatever the exponents are on the inside, we have this situation, a power to a power. We can just multiply a times b, or both the exponents together. I'm going to show you both ways to do this. That rule is not so important. I would rather we understand what's going on here. So we have this term, -3a squared, b to the third, and that is all to the second power. That means we're going to multiply this thing twice. Just like that. Okay? And once again, we want to reorder things. Get our numbers first. -3 times -3. And that is +9. Two negatives multiplied together give us a positive. A squared times a squared. This is 2a's times 2a's. A times A times A times A. That is 8 to the fourth. And then we have our b's. B to the third times b to the third. You can see the shortcut is you can add the exponents when we multiply. So 3b's multiplied together plus 3b's multiplied together, we get 3 plus 3 is b to the sixth. Or you can always write that out. That means b times b times b times b times b times b. We've got 6 of them. This should be our answer right here. 9, a to the fourth, b to the sixth. Now if you want to go ahead and use that rule, we can. This means -3 times -3, which is 9. 2 times 2, we get a to the fourth. 2 times 3, we get b to the sixth. Okay? So we do end up getting the same answer. But I like for us to know that this is what's happening. And if we're comfortable using that shortcut, we can. We have those exponent rules or whatever that we've been using. For instance, one of those exponent rules I did mention during this problem, if you have the same base, you can add your exponents. So a to the fourth, 2 plus 2. If you have the same base again, b and b, 3 plus 3 got us here. So we do have rules that we can use. Like I said again, in this situation, you can multiply power to a power. 2 times 3 is 6, 2 times 2 is 4, and then this to the second power. So it's up to you. I would rather we do it this way until we're very comfortable with those laws, which we will be. We will get a handle on those in the next year and bring those into high school algebra with us. All right, that's all I have for today.